223 Remington. For over 1 century, brass has been the undisputed king of the range. But look closely, that reign is facing a high-tech coup d'etat. This is the 223 Remington from True Velocity. And let's be honest, it looks more like a futuristic fuel cell than a traditional bullet, while your standard brass case is a heavy 168 grains. This polymer disruptor strips that weight down by over 30%. When you slap a full 30-round mag into your rifle, you'll feel it instantly. The balance shifts and the fatigue just vanishes. But the real secret sauce isn't the weight, it's the thermodynamics. Brass is a heat sponge. It sucks up the explosion and cooks your chamber. This polymer, it's a heat shield. This means your bolt carrier group stays cool to the touch, while your throat erosion is slashed to a fraction. We are witnessing a total divorce from heavy metals in favor of aerospace-grade chemistry. Imagine firing hundreds of rounds and being able to touch your chamber without a third-degree burn. 556 by 45 mm NATO. Now, let's go from the flat range to the front line. This is where things get brutal. The 556 mm NATO by True Velocity isn't just lighter, it is a survival tool. Infantry life is a game of inches and ounces. And this round handles chamber pressures screaming past 62,366 pounds per square inch, where brass expands and occasionally chokes your rifle under stress. This composite stays rock solid and dimensionally perfect. The payoff. A standard combat load that used to weigh you down now feels 5 pounds lighter. 5 pounds. That is more water. Extra night vision batteries, or another trauma kit that could save a life. In the grit and mud, where ounces equal pounds and pounds equal pain, this tech is literally saving the joints of our soldiers. It's a masterclass in efficiency. You aren't just carrying ammo, you are carrying endurance. Because at the end of a 12-mile ruck, the guy with the polymer mags is the one who still has the steady hands to make the shot count. 308 Winchester. Skeptics believed a rifle round made of plastic would simply shatter under violent recoil. But the 308 Winchester didn't just survive, it conquered. This was the moment the polymer revolution proved it belonged in the big leagues. We're talking about 45 to 50 grains of propellant kicking a heavy projectile downrange at 60,000 pounds per square inch. True Velocity didn't just build a case. They built a synthetic fortress that refuses to fail. For the mountain hunter in Montana, this is the ultimate gear upgrade. Carrying a box of 20 polymer rounds on your belt feels like nothing. It's a ghost. But when you pull the trigger, the consistency is hauntingly good. Because these cases are molded, not stamped. The internal volume is identical every single time. It's a seamless marriage of aerospace tech and the soul of the American bolt-action rifle. You get the weight of the future with the reliability of a legend. Muzzle velocities are so stable, they'd make a handloader weep with joy. 762 by 51 mm NATO. Let's talk about suppression. When you're behind an M240 machine gun, heat is your absolute enemy. It leads to cook-offs, where the chamber gets so hot, the round ignites itself. But because polymer is a natural insulator, it refuses to let thousands of degrees of heat soak into your steel. This thermal barrier keeps your weapon's operating temperature significantly lower, meaning you can keep barking downrange while other guns are seizing up. A standard link of 200 rounds of brass 7.62 mm is a heavy metallic anchor. Switch to polymer, and suddenly, that same soldier can carry nearly an extra 100 rounds for the same weight penalty. Imagine the lethality of a squad that never has to say, "I'm Winchester," because they're carrying 30% more lead. It is a masterclass in material science, where the ammunition itself acts as a cooling system. In the chaos of a heavy engagement, this tech ensures the gun stays cool, the ammo stays light, and the fire superiority stays on your side. 6 5mm Creedmoor. For the long-range marksman, the 6 5mm Creedmoor is the gold standard of efficiency. But true velocity takes that precision and moves it to a molecular level. Long-range shooting is a game of variables, and the biggest killer of a tight group is inconsistent muzzle velocity. Traditional brass is highly conductive, meaning heat from a sun-baked barrel or a 10th shot quickly seeps into the powder. True Velocity's composite acts as a thermal vault, keeping your propellant at a constant temperature regardless of how hot your barrel gets. This results in extremely low standard deviations in velocity. When dialing in for a 1,000-yard shot, you don't have to guess if your cold-bore shot will act differently than your warm one, because these cases are molded with surgical precision. The internal volume is identical every single time. Consistency even meticulous hand loaders dream of. Master the wind and the thousands of feet between you and the target. 260 Remington. While the Creedmoor gets the headlines, the 260 Remington is the insider's choice for elite tactical shooters. PCP ammunition understood a critical flaw in high-pressure rifles. Brass expands and can seize against chamber walls, leading to the dreaded sticky bolt. Their solution: a high-strength technical resin that recovers its original shape almost instantly after the pressure drops. This elastic memory ensures that extraction is lightning fast and smooth, even when you're pushing the rifle to its absolute limits. In a precision match, a single jammed casing is the difference between a podium finish and going home empty-handed. The 260 Remington also offers a weight advantage for mountain hunters who count every ounce while climbing vertical terrain. You get the same heavy-hitting performance as brass, but with a modern twist that prioritizes mechanical reliability. When you combine a high ballistic coefficient with a case that refuses to bind, you get a system smooth as glass. 6. 8mm PCP. The sixth 8mm PCP is a fascinating study in finding the ballistic sweet spot. It fills the massive gap between the light 556mm and heavy 7.62mm without the weight penalty of a battle rifle. Unlike brass, which is limited by metal drawing properties, polymer injection molding allows PCP to customize internal geometry to perfection. The result is a cartridge delivering a devastating kinetic punch while fitting perfectly into the lightweight magazines of next-gen carbines. This is why the 6.8mm is a focus of military testing. It offers the lethality of a larger round with the controllability of a smaller one. Because polymer walls are thinner yet stronger than brass, they hold more propellant, pushing velocities higher than ever. For the shooter, this means more energy on target and less weight on the belt. It's a weapon system that finally feels like it belongs in the 21st century. 6. 8mm TVCM. The sixth 8mm TVCM is arguably the most famous cartridge on the planet, the crown jewel of the next-gen squad weapon program. Most revolutionary designs require expensive new platforms, but the genius here is the drop in capability. By keeping the same rim dimensions as existing calibers, True Velocity created a monster that works in current rifles with just a simple barrel swap. This round produces terrifying muzzle velocity and energy outperforming the 7.62mm NATO. Yet it weighs less and generates less back pressure. It is the bridge between the old guard and a new era of American fire superiority. During Army testing, this polymer beast withstood extreme pressures that would cause a brass case to rupture or flow into the bolt face. For the average soldier, this means having the reach of a sniper in a package as light as a standard carbine. It represents a paradigm shift where the cartridge is a high-performance component. The sixth 8mm TVCM is a total tactical overhaul. 338 Lapua Magnum. Welcome to the world of extreme long range. The 338 Lapua Magnum is a legend among snipers, but its size is a logistical nightmare. A single box of 20 brass rounds feels like carrying a literal brick in your rucksack, weighing nearly 2 pounds. PCP ammunition tackled this by applying high-strength polymer to this heavy hitter, slashing the weight of a 10-round magazine by a staggering margin. This allows a sniper team to carry nearly 50% more ammunition for the same weight, extending their time in the field during deep recon. Beyond weight, the polymer case is a critical heat sink. The 338 Lapua burns a massive 90-plus grains of powder, generating heat that can erode a steel barrel in fewer than 1,500 rounds. By insulating that heat within the polymer wall, the throat stays cooler, preserving the match-grade accuracy snipers depend on for survival. Switching to a lighter material actually increases the lifespan of the entire weapon. For the man behind the glass, it means a rifle that stays precise until the mission is done. 338 Norma Magnum. The 338 Norma Magnum fuels a new breed of machine guns, the LWMMG. In the past, if you wanted the range of a .30 caliber, you hauled a 100-pound M2 Browning. Not anymore. This polymer-cased Magnum delivers an effective range of over 2,000 yards in a system a single soldier can operate. The polymer cases are so efficient that a belt of 500 rounds is 35 pounds lighter than brass, making a machine gun team as mobile as a rifle squad. Safety and reliability under sustained fire are where this round earns its stripes. During rapid fire, polymer cases are ejected while holding most combustion heat, preventing the dangerous cook-off threshold. This means N240-style platforms can maintain higher rates of fire without risk of accidental discharge from a blistering hot barrel. It proves modern polymers handle the violent, high-speed cycling of belt-fed weapons without tearing. In the chaos of a heavy engagement, this technology ensures the lead stays flying while the gunner stays moving. 50 BMG. When we talk about the 50 BMG, we're discussing the heavy hitter that has defined devastation for 1 century. Traditionally, 1,000 rounds of this monster in brass weighs nearly 300 pounds, a massive burden for any aircraft. Mac LLC and Nammo changed the game with the first polymer-cased 50 caliber officially fielded by the U.S. Marine Corps. By slashing the weight of each cartridge by 25%, they've allowed attack helos to save fuel or bolt on extra armor without exceeding takeoff limits. This isn't just a prototype, it's serving on door-mounted M2 machine guns right now. The polymer construction reduces abrasive wear on feeding chutes, vital when firing at 500 rounds per minute. For flight crews, it means more trigger time and less fatigue when reloading massive ammo cans in high-stress zones. This ensures the most powerful machine gun in the American arsenal remains relevant and mobile for the next generation of aerial combat. 556mm CT-cased telescoped. Textron Systems has rewritten the rulebook with 5 56mm cased telescoped ammo. This is a radical departure from the bottleneck shape used since the 19th century. Instead of the bullet sitting on top, it is now buried deep inside a cylindrical polymer tube, surrounded by propellant. This telescoped design reduces overall length by over 35% while maintaining full NATO performance. This breakthrough allows for a push-through feed mechanism that is simpler and far more reliable than any traditional bolt design. Imagine a weapon system nearly 40% lighter than an M4 carbine, but with the same lethality. Because the round is a perfect cylinder, it stacks efficiently in magazines, allowing a soldier to carry more fire in a much smaller footprint. The polymer case also acts as a natural seal, protecting powder from moisture in harsh jungles or deserts. It represents the death of the traditional brass shell. The future of infantry combat isn't just better guns, it's rethinking the very shape of the energy we throw downrange. 7 62mm CT-cased telescoped. Moving up to the 7 62mm CT variant, we see how this technology solves the age-old stovepipe jam. In traditional machine guns, spent brass must be pulled backward out of the chamber, a process prone to failure under heat. with Textron's polymer cylinder. The firing chamber moves independently, allowing fresh rounds to simply push empty cases straight out the front. This linear movement eliminates almost every major cause of mechanical malfunction, making a machine gun virtually impossible to jam. For the gunner, this means a weapon 30 pounds lighter than a standard M240, while providing the same suppression. The reduced length of CT ammo means the actual receiver can be made much shorter, perfect for armored vehicles or tight urban corridors. It's a masterclass in efficiency, where every grain of powder and every millimeter of space is optimized. By removing the rim and neck, Textron created a system that feels more like a precision machine than a firearm. This ensures big-bore fire remains mobile and lethal. 6. 8mm CT-cased, telescoped. Finally, we arrive at the absolute pinnacle. The 6th 8mm cased telescoped round. This is the all-in-one solution the military has dreamed of for decades. A cartridge combining carbine portability with battle rifle armor-piercing power, because the projectile is nested inside propellant. The 6th 8mm CT offers devastating energy well beyond 600 yards while remaining incredibly compact. It is the most advanced ammo ever developed for the individual soldier, representing a total divorce from the metal technology of the late 1800s. This is the future of American fire superiority. In trials, the 6th 8mm CT punched through modern body armor that standard 556mm rounds cannot touch. By utilizing ultra-lightweight polymer cylinders, soldiers carry a full load of high-powered ammo with less strain than traditional loads. It is the holy grail of ballistics: more power, more range, and significantly less weight. As we look toward the battlefields of tomorrow, the 6th 8mm CT stands as proof that the era of brass is over. The age of high-performance polymer has begun.